Hi folks, Joseph Kursky here with you. Let's talk about calculating the mean center and standard deviational ellipse in ArcGIS Pro. The mean center and standard deviational ellipse in ArcGIS Pro. Let's analyze zebra mussels data through the analysis of the mean center. If you've got your zebra mussels, or any data, but I'm just using zebra mussels, invasive species as an example, in the contents pane in ArcGIS Pro, in the selection group, you're going to select by attributes to begin a new selection. You're going to add expression and you're going to select the zebra mussels that appeared in 1995, the reasons which will become clearer later. So we're just going to select a subset of the data. Then we're going to search for the tool called Mean Center. And in ArcGIS Pro Help, you can find more information about the Mean Center tool and what it does and why it does it. Then, find and use the Mean Center tool to calculate the mean center for the zebra mussels. It will only consider the mussel sightings from 1995, which is the ones you selected a bit ago. So once you run that tool, your result will be saved as a feature class inside your geodatabase. When done, you will symbolize your 1995 mean center point so that it's easily distinguishable from the rest of the zebra mussels data. Next, analyze your zebra mussels data through the analysis of the directional distribution, which is also known as the standard deviational ellipse. Use the search tool to search for the tool entitled Directional Distribution or Standard Deviational Ellipse in ArcGIS Pro. What is directional distribution? Well, there's documentation on that tool as well. It's a powerful tool. Use Select by Attribute now to select the zebra mussels that appeared in 1995, if you haven't already done so. And then you're going to calculate the directional distribution for the zebra mussels in that year. Now, once you do that, I'm going to ask you to think about the shape, the length, the width of the directional distribution for the zebra mussels during that year. And then I encourage you to repeat the above procedures to calculate the directional distribution for zebra mussels in other years, such as 2005. How did the directional distribution for zebra mussels change from 1995 to 2000 to 2005? Why did it do so? Examine the attribute data. What would have been the problem with comparing 1986 and 2011 data to 2000 data in your mean center and distribution analysis? Why do you think it's better to use 1995 and 2005 as your start and end years? I'll give you a little hint. The reason is because the data for those other years is not complete. So your result, it would have done it in your GIS, but it would have been flawed. It would have had less confidence, less authority in the result. So mean center and standard deviational ellipse are ways of figuring out the center point for your data. It's like the mean center is balancing all of the point data, in this case zebra mussels, on a pencil tip. If you could do that, what would be the point that that distribution of data would balance on that pencil point? Now it could be tree species, it could be weather observations, it could be graffiti locations in your community, it could be dangerous intersections in your community, it could be art or public gardens in your community, etc. But the mean center of those points, and it changes over time if your data changes over time, as is the case in zebra mussels. And the standard deviational ellipse is, and you can find more documentation in ArcGIS Pro, the standard deviational ellipse is, it gives you how many points are within one standard deviation of the mean center for that distribution of points. So you know what a standard deviation is in statistics. This is a mapped version of the standard deviation. So it gives you how many points are within one standard deviation of the mean center, which is fascinating because in the case of zebra mussels, you can see not only does the mean center and the standard deviational ellipse move, but it also the standard deviational ellipse changes shape as the distribution of zebra mussels, sadly, well, I say sadly because it is an invasive species, so it's not a good thing that these things are spreading around, but as they spread around, the shape of the standard deviational ellipse changes. So these tools are powerful. Now why use these? Not just to gain new GIS knowledge, but remember, like I was saying in other videos, the goal is to figure out how things are the way they are. Why? The whys of where. That's the goal. And so if you figure out the whys of where, you can say, okay, this is what we can do in this case to mitigate, to thwart, to reduce the spread of zebra mussels. Why is that a problem? Because zebra mussels, like other invasive species, displace naturally occurring species. So that's why you see these signs, for example, along reservoirs and rivers saying, hey, make sure your boat doesn't have any water in it. And here's a boat inspection station, and we're going to help you make sure your boat doesn't have any water cavities. Why? Because in those water cavities could be zebra mussel, could be hiding in there. And that's how they migrate, right? They don't have legs and they can't swim and stuff. They attach themselves to boats. That's primarily how they move. So by using GIS and spatial thinking, we can figure out how these things are spreading and try to solve the problem. Thanks.